Hello everyone, this is a video lesson on vectors. For you to better understand this topic, it is expected that you have already mastered the right angle trigonometry. So for example, you want to calculate sine theta, you should divide the opposite side with the hypotenuse. Or if you want to get the y component of r, you have to multiply r with the sine theta. On the other hand, if you want to calculate for the cosine theta, you have to divide the adjacent side with the hypotenuse. While if you want to get the x component of the r, you have to multiply the r with the cosine theta. Lastly, if you want to calculate for the tangent theta, you have to divide the opposite side with the adjacent side. And if you want to get the r square, you should add the x square or the square of x with the square of y. Before we proceed to our discussion on vectors, let's first describe or define what a scalar quantity is. A scalar quantity is a quantity that contains magnitude only, and it also consists of a number and a unit. For example, here in the figure, so this represents a distance. So a distance is the length of the actual path taken by an object. So this is an example of a scalar quantity. So as we notice here, the total path taken from A to B is 20 meters. So other examples of scalar quantity is speed. Let's say for example 40 miles per hour, or volume 10 gallons. On the other hand, a vector quantity is a quantity that contains a magnitude and direction. So of course, there is a number that represents the magnitude, the unit, and of course the angle that represents the direction of the vector. So this is an example of a vector quantity. So for displacement, it is the straight line separation of 2 points in a specified direction. In short, this is the shortest distance between points A and B. So when we talk about displacement, we are not concerned with the total path taken, but we are only concerned with the shortest, again, the shortest distance between A and B. In this case, this is 12 meters, and it is directed towards 20 degrees with respect to the x component, or the positive x axis. This is another example that shows the difference between distance and displacement. So for example, you traveled from 4 meters going east, and then from there you also traveled 6 meters west. So the displacement here is the distance between your initial position and then your final position, which is, okay, the net displacement is 2 meters west. On the other hand, the total distance traveled is 10 meters, since you have to add 4 and then 6. In most cases, when we deal with vectors, we have to identify the direction, and in order to do that, we have to use east, north, west, and south as a reference. So for example, in this point here, so let's say this is 14 meters away from the origin. So this is the distance. However, if you want to express this as a vector, so this vector is 40 meters 50 degrees north of east, and the angle, notice that the angle is measured with respect to the positive x-axis. So that's why it's north of east. On the other hand, this vector is now 40 meters 60 degrees north of west. The third one is 40 meters, but this time, since it's measured with respect to the y-axis, negative y-axis, so it's 60 degrees west of north. But this time, ito, number 4, this is 40 meters 60 degrees south of east. Another example, when you were asked to write the angles shown below by using references to east, south, west, and north, take time to pause this video and think of the correct answer. Now here are the answers. So this vector here is, or this angle here is 50 degrees south of east, while this angle is 45 degrees west of north. When we want to present vectors, one good way to express it is through polar coordinates r theta. So consider the vector 40 meters, 50 degrees north of east. The graph of this is this. Okay, so the length 40 meter, or r, or so the length of the vector is represented by r, and this angle is represented by theta. So r is the magnitude and theta is the direction. For example, 40 meters 50 degrees looks like this, while this is 40 meters 120 degrees. So if we measure, the angle is measured from the positive x-axis. On the other hand, this is 40 degrees 210. Again, if we measure the angle from the positive x-axis, this is 210. And then lastly, this is 40 meters 300 degrees. So again, if we measure the angle from the positive x-axis. Now another way to present vectors is through rectangular coordinates, in which the reference is made to x and y axis with positive and negative numbers to indicate the position in space. So for example, this is positive 3, positive 2. So which means it is 3 units away from the origin on the positive x-axis, while it is 2 units up on the positive y-axis. While this one is negative 2, 3, which is negative 2 units away from the origin to the negative x-axis, while it is 3 units up on the positive y-axis, and so on. Now let's review again some of the trigonometry concepts that we need in order to understand vectors more or better. So for example, again, sine theta is equal to y over r, while cosine theta is x over r, and lastly tangent theta is y over x. A better way to remember this is through so, ka, then towa. So sine is equal to opposite over the hypotenuse, cosine is adjacent side over the hypotenuse, while tangent is the opposite side over the adjacent. Now again, if we want to solve for y, or the y component, this one, okay, we have to multiply r by the sine of theta. So this is theta. And then to get x, we have to multiply r, which is the hypotenuse, with the cosine of this theta. And lastly, if we want to get the value of r given the values of x and y, so we can just get r is equal to the square root of x squared plus y squared. Now let's use those concepts in solving this problem. So let's say, for example, find the height of a building if it casts a shadow 90 meters long and the indicated angle is 30 degrees. Now take note that the height, this height here, is opposite with the angle 30 degrees here. So this is theta. And the known adjacent side is 90 meters here. Now we can solve this by using tangent theta, which is equal to the opposite side over the adjacent side. Okay, now so let's substitute the given value. So tangent theta, or tangent 30 degrees, is equal to the opposite side, which is h, divided by the adjacent side, which is 90. Okay, so now to get h, Okay, so h is equal to 90. So we multiply this 90 with tan 30, so that's 90 meters. Tangent times tangent 30 degrees, and that would be equal to 52.0 meters. So h is 52.0 meters. Now, if our angle is expressed into polar coordinates and we want to convert it to rectangular coordinates, we have to find its components. So a component is the effect of a vector along the other directions. So the x and y components of a vector, r theta, are illustrated below. So this is the x component of this vector r, and this is the y component. Now, in order to solve for r, or to x, so again we have to multiply r with the cosine of theta. And to get y, so we have to multiply r with the sine of theta. So this is because cosine theta is opposite, or adjacent over hypotenuse. So if you will get, the adjacent side of this theta is x, and then this is r. Now, so if you want to isolate x here, so you have to multiply r, so therefore it becomes x is equal to r cosine theta. And at the same time, sine theta is equal to opposite over hypotenuse, which is equal to, so the opposite side is y, while the hypotenuse is r. Now, if you want to isolate y here, so you have to multiply r with sine theta. That's why it became y is equal to r sine theta. Now, to give you an example, suppose a person walks 400 meters in a direction of 30 degrees north of east. How far is the displacement east and how far north? So to get the displacement east, so we have to get the x component, and to get the displacement far north, so we have to get the y component. Now again, the magnitude is 400 meters, so therefore r is equal to 400 meters, while theta here is equal to 30 degrees. Now, given the formula earlier, so x is equal to r cosine theta. Therefore, we have to multiply 400 meters by cosine theta, which is cosine 30 degrees. And then that is equivalent to positive 346 meters. And then since it's going to the positive, or to going east, so we must put e. So this is x, so this is the displacement towards east. Now to get y, so y is equal to r sine theta. So again, so we have to multiply 400 meters with sine of theta, sine 30 degrees. So that is equivalent to positive 200 meters north. So previously we converted polar coordinates to rectangular coordinates. Now this time, let's convert rectangular coordinates to polar coordinates. Now, given x and y, so how do we get r? So to get r, we have to use again the Pythagorean theorem, which is r is equal to the square root of x squared plus y squared, while theta, so tangent theta is equal to y over x. Now to get theta, so that is equivalent to arctan y over x. So again, r is always positive and theta is from the positive y-x axis. So to give you an example, let's say a 30-pound southward force and a 40-pound eastward force act on a donkey at the same time. What is the net or resultant force on the donkey? So to get the resultant force, again we have to use the formula R is equal to square root of x squared plus y squared. So which is equal to the square of x is 40 square plus y is 30 square. So which is equal to 50 pounds. Okay, now to get theta, so that's tangent theta is equal to negative 30, negative because it's going down, and then divided by 40. So now tan theta is equal to arctan negative 30 over 40, which is equal to negative 36.9 degrees. And it is also equivalent to 323.1 degrees. Okay, so this is your theta and this is your R. Now let me introduce you another concept which is known as the unit vector notation. So a unit vector is a vector of length 1, which is also sometimes called as direction vector because it indicates direction. Now, so consider the 3D, three-dimensional axis x, y, and z. So we also define unit vectors I, j, and k, or we can also say I hat, and then j hat, and k hat. So now I hat is directed towards y axis, and then j hat is directed towards the y, and k or k hat is directed towards z. Now for example, we can say that 40 meters east is 4 I hat, and 40 meters west is negative 4 I hat. And similarly, we have 30 meters north. We can also say that it is 30 j hat, and 30 meters south is negative 30 j hat. And lastly, 20 meters out, which is going out of the page, is 30k or 20k or k hat, and 20 meters in or going into the page is negative 20k hat. So for example, a woman walks 30 meters west, then 40 meters north. Write her displacement in ij notation and in r theta notation. So in ij notation we have, okay, so r is equal to rx, I, which is the x component of r, plus ry, which is the r component of y, j hat. Okay, so again, rx is negative 30 since it's going to the left. Ry is positive 40 since it's going up. Therefore, the ij notation is negative 30i plus 40j. And the displacement is 30 meters west and 40 meters north of the starting position. Now, if we want to get the r theta notation, so we can get theta, okay, using tangent arctan 40 over negative 30, which is negative 53.1. So therefore, if it will subtract that to 180, or from 180, so that is 126.9. Now to get the value of r, so again let's use the Pythagorean theorem. So negative 30 square plus 40 square, that is equal to 50 meters. So therefore the r theta notation is 50 meters, 126.9 degrees. Another example, town A is 35 kilometers south and 36 kilometers west of town B. Find the length and direction of highway between towns. Now in this problem, we have to get the resultant vector r and then theta, okay, or phi. Now, to calculate r, so this is the ij notation. So negative r is equal to negative 46i minus 35. So negative, since it's going to the left, and then negative, again negative 35 since it's going down. So r is equal to 46 square plus 35 square, so that is equal to 57.8 kilometers. Again, this is positive since it's a scalar quantity. So this serves as a magnitude. Now, if you want to get the direction, so tan phi is equal to negative 46 km over negative 35. Now to get the angle, so phi is equal to 52.7 south of west. Therefore, the final answer, if you want to subtract, if you want to get the total, or I mean the angle, sorry, from the positive x direction or x axis, so here, so this angle from here, so we have to add 180. So since this is 180, so from this point up to this point is 180, and then another, this is 52.7, so we have to add, so that's why we got the 232.7. Next example, find the components of 200 Newton force exerted by the boy on the girl if his arm makes an angle of 28 degrees with the ground. So notice that this is conversion from polar coordinates to rectangular coordinates. That's why we have to get the f and y components of the force. So which is fx, or the f component is 240 newtons cosine 28, and then we have to put the negative because then on the x component, the force, or the component, the f component, x component of f is directed towards the left, or the negative x direction, while fy, so it's positive, so since it's going up, so that's 240 sine 28, so which is equal to 113 newtons. And in ij notation, that would be f is equal to negative 212 I hat plus 113 newtons j hat. Now, what if we have more than two vectors? So for example, a boat moves 2 km or 2 kilometers east, then 4 kilometers north, then 3 kilometers west, and finally 2 kilometers south. Find the resultant displacement. So again, we have to look for the displacement, or the resultant displacement, but this time we have more than two vectors. So for the first one, start at the origin, then draw each vector to scale with tip of the first. So this is the tip of the first, and then tail of the second. So this is the first angle, or the first vector, and then this is the tail. So this is the tip of the first angle, or the vector, I'm sorry, and this is the tail of the first vector, and then this is the head to tail method, and so on. Next is draw the resultant from the origin to tip of the last vector, noting the quadrant of the resultant. So here is the resultant vector. So this is the tip, or the tail of the first vector. while this is the tail of the final vector or the last vector. Note that the scale is approximate, but it is still clear that the resultant is in the second quadrant. Now here, if we draw this, so it's still on the second quadrant. So to find the resultant displacement, we write each vector in ij notation. So the first vector is positive 2i, since it's going to the positive direction. Vector b is positive 4j, since it's going up. C is negative 3i, since it's going to the negative direction or going to the left. And lastly, d is equal to negative 2j, since it's going down. Now add the vectors a, b, c, and d algebraically to get resultant in ij notation. So we just simply add. So this is positive 2i and then negative 3i, so that is negative 1i. And then positive 4j and negative 2j, that's equivalent to positive 2j. Now 1 kilometers west and 2 kilometers north of the origin. So this is the ij notation. Now convert to r theta notation. Now from this ij notation, we can calculate for the resultant r using the Pythagorean theorem, which is square root of negative 1 square plus 2 square, so that is equal to square root of 5. Therefore, the magnitude of r, or r, is equal to 2.24 kilometers. And then to get the angle here, angle phi, so angle phi is the angle between this angle or this vector and the x-axis nearest to it. Therefore, we can calculate phi as 63.4 north of west. Another example, so find the r theta for the 3 vector displacement below. So for A, so that is 5 meters 0 degrees. For B, it's 2.1 meters 20 degrees, and C 0.5 meters 90 degrees. So we can draw A like this. So since 0 degrees, it's going to the positive x-axis. And then B, 2.1, so the angle is measured from the positive x-axis, so that's 20. And then lastly, 0.5, which is going up, since the angle with this is 90. Okay. Now, first draw the vectors A and B and C to approximate scale, indicate angles. So this is just a rough drawing. So draw the resultant from origin to tip of the last vector, noting that the quadrant of the resultant are theta. So now we will start from this, and then we should end here. So here's the resultant vector. R is the length or the magnitude of this vector, while theta is the angle between this x-axis and this vector. Now write each vector in ij notation. So we can write the here, okay, as shown. So this is component method. So A, if the angle is 0, so the x component is 5 meters, while the y component is 0, since it has no y component. For B, so to get the x and y components, again, we use the formula x is equal to r cosine theta, while y is equal to r sine theta. Now, to get x, that's positive 2.1 cosine 20 degrees. Take note of the sign here. So it's positive since it's going to, this is the x component. So this is b x, and here this is by. Okay, so that's why bx is this 2.1 cosine 20 and by is 2.1 sine 20 here. Okay, so for C, there's no x component, it's going up, while positive 0.5 meters as the y component. Now we can just simply add this. So Rx, okay, or the total component, x component, so that is ax plus bx plus cx, and then similarly for y component, ry, so ay plus by plus cy. Now, so we can calculate it and then add the vectors to get the resultant r in ij notation. Okay, so we can express this 5 meters as 5i plus 0j, the 1.97i plus 0.718j, and then c is equal to 0i plus 0.5j. So we can just simply add that, and then we will get 6.97i plus 1.22j. So this is the ij notation. Now here's the diagram for that. So r now, we can draw 6.97 as this. So this is x component, and 1.22 here. And then to get that r, so again we use the Pythagorean theorem. 6.97 square plus 1.22 square, so that is r is 7.08 meters, while tangent phi is 1.22 meters over 6.97 meters. Therefore we can get theta is equal to 9.93 degrees north of east. Now if we can get the sum of vectors, we can also get its difference. So for vectors, signs are indicators of direction. Thus, when a vector is subtracted, the sign or the direction must be changed before adding. So in short, it's the process similar with the addition of vectors, but in this case, before you add, you have to change the direction first. So for example, we have to subtract b from a, so a minus b. So since we will subtract b from a, we have to change the direction of b and then turn it to the opposite direction. So this would become like this, and then again we can get the r, or the resultant vector. Now to give an example, given a is 2.4 kilometers north and b is equal to 7.8 kilometers north, find a minus b and b minus a. If we will draw a and b, they both have, or they are both directed towards north, so they should go upwards. So a, again, its measured in its measurement is 2.43 kilometers north, and then b is 7.74 kilometers north. So to solve for to get the resultant vector a minus b, so we have to draw a first, so it should go up, and then since we subtract b from a, so we have to change the direction of b, so from upwards it becomes downwards. So now the resultant vector should start from the point in which a started, and then it should point where the b, or the second vector, ends. So as you can see here, the resultant vector is going down. So 2.4 north minus 7.74 kilometers south, that should be 5.31 kilometers south. But if we will get b minus a, so we will draw b first, so we will draw it upwards, so that's positive b, and since we will subtract a from b, a must be drawn downwards. So here the resultant vector should look like this. So since we will start from the point in which B started, and then it should end at the point in which A ended. Okay. Now 7.74 kilometers north minus 2.43 kilometers south, that should be 5.31 kilometers north. So that's how you subtract vectors. Now let's go